Guess what? If you live in Norway, you've already used a product we built, but never knew it. The 99X Group has established itself as a leader in product engineering services, web solutions, and sourcing tech experts. We have built a solid foundation, and now 7 companies from Norway, Sri Lanka, Malaysia, Brazil, and Portugal combine to form a tech powerhouse. The 99X Group serves clients in Norway, Sweden, Germany, across Europe, and North America. With over 600 employees worldwide, we are set to become one of the industry's most sought-after tech players. What sets us apart is our combination of local presence, global access to talent, and proven capability of delivering value with multinational teams. We attract the top 1% of tech talent with a passion for deep tech innovation. This enables our customers to create exceptional product experiences, to rapidly scale their own teams with top-tier local and nearshore engineering talent, and to build appealing web solutions and business-critical systems. "99X. Boost your digital potential."
Good evening, everyone. Welcome to Quality Week 2025, organized by Colombo Quality Camp, a highly anticipated online conference dedicated to quality assurance and software excellence. This year's event proudly features 15 insightful sessions with a distinguished lineup of 5 international speakers and 11 prominent Sri Lankan speakers who will share their expertise and insights, making it an unmissable occasion for professionals in the IT field. I am Dharana, your host for today, and I have Thivinya as my co-host.
Hello, everyone. We are delighted to have all of you join with us for this incredible event, filled with knowledge, insights, and thought-provoking discussions on software testing and quality engineering. Before we start, we would like to take a moment to recognize and appreciate our valued sponsors who helped to make this event possible. First, a big thank you to 99X, our strategic partner. 99X is a leader in the digital product engineering, empowering businesses with innovative solutions and cutting-edge technology. We also extend our gratitude to our educational partner, ISTQB, the globally recognized authority in software testing certification. Their commitment to quality and excellence helps shape the future of software professionals worldwide. Before starting the session series, the welcome note will be delivered by Dilhani Disanayake on behalf of Colombo Quality Camp. Over to you, Dilhani.
Hello, everyone. Good evening and welcome you to Quality Week 2025, the event dedicated to innovation, excellence, and continuous improvement in quality practices. The CQC team is proud to announce that this year marks the 5th consecutive year of Quality Week, which has expanded to reach both local and global audiences. This year, 280 plus participants registered to engage in this experience. So we are thrilled to celebrate this milestone with all of you. Over the next few days, you'll have the privilege of engaging 15 insightful sessions led by industry experts, thought leaders, and professionals who are passionate to drive quality to the next level. We sincerely appreciate your active participation in the Q&A sessions and your enthusiasm throughout all 5 days. Let's make Quality Week 2025 a remarkable experience for everyone. So on behalf of the CQC team, I warmly welcome all of you once again. Let's continue the journey toward excellence. Thank you very much.
Thank you, Dilhani, for the welcome note. As we are about to start today's sessions, please note that if you have any questions for the speaker, please share them in the chat. We will address them one by one with the speaker after the session. So now let's dive straight into the keynote of Quality Week 2025, presented by a renowned expert in software testing. It is our privilege to introduce our keynote speaker, Julio de Lima, QA Manager at Capco. Julio de Lima is a specialist in software testing with 15 years of experience. Julio has a bachelor's degree in software engineering, a specialization in teaching in higher education, and a master's degree in electrical and computational engineering with a focus on testing and artificial intelligence. He currently lives in Orlando, Florida. He serves as a principal QA automation engineer at Capco, helping financial institutions establish robust and sustainable testing strategies. He uses his coding and architecture skills to contribute to software quality at all system layers. Julio has contributed to the software testing community through his channels on YouTube, Instagram, and Spotify, and in articles for technical and scientific magazines. He has experience as a speaker at national and international events. Julio is a Star East alumnus, being a speaker in 2020, 2023, and 2024. Julio also has trained more than 12,000 students through his online training in Portuguese. Today, Julio will be sharing his insights on AI-driven approaches for API testing. Please join us welcoming Julio de Lima.
Thank you so much for this introduction, guys. It's a pleasure to be here today. And I would like to start by saying thank you for everyone in the backstage of this conference. It's a very pleasure to be part of it and to see how you guys are building a strong and healthy community. So for everyone that is here today, thank you for joining me. It's a very important moment for me in my career. This is my first time speaking at this conference, and I was really looking forward to be here today. I will share my screen to show you guys the slides that I brought today. Actually, it's not only slides, I have also demos. So the idea is to discuss a little bit more about what are some of the strategies, some of the approaches that I've been using to test APIs from an AI-driven perspective. I think that the guys already gave a very good introduction about myself. I would like to just share one more part that is at Capco, that is the company that I work for, a consultants firm and that focus more in technology for the financial field. We have been investing a lot of time to try to understand how AI can help in software testing. And my role at Capco United States is to serve as a PM as well. Apart from the QA management stuff, I also serve as a PM for the products that are driven by AI. So everything that we have for testing driven by AI is something that is part of the activities that me and my team have been doing so far at Capco. Okay, and during this learning, because it's a how to say it's a really a path, a learning stuff. We had the opportunity to test a lot of strategies on how to help the tester when testing applications. And the 6 strategies that I'm going to show you guys today are all related to some of the experiments that we already did at Capco. If you want to know more about Capco, or if you want to reach out to me afterwards, this is my mail, julio.lima@capco.com. You can take a screenshot here, just reach out to me. I will be more than happy to help you guys on whatever you need, okay? So let's start with the content itself. When we talk about APIs, generally we think about the backend, the whole backend, right? However, APIs are just a entry point, right, to the whole backend. Behind the scenes, and when I say behind the scenes, I'm talking about behind the UI interface. We have the APIs, and the APIs are kind of a bridge between the front end and whatever we have at the backend. I created this diagram just to give you guys a little bit more context about it, right? You will see here in this diagram at the left side or UI interfaces and even other APIs that are calling our API. And behind this API, we have, as I said before, lots of components. The ones that you see here are the services that basically is where the business rules are implemented. So if you guys have access to the code base that the development team works, you probably will be inside these services. A lot of conditions or business rules, as I said before, and then you'll be able to understand how the software thinks. We also have repositories that can be used to access some storage. We also have clients that are basically visualizations and communication with external services. As you can see on the top, there is another API. This other API is an external API. And you see here that clients are connecting straight to those APIs, but those APIs are not under our control, right? We also have SQL, NoSQL, and also Q. And all this universe is behind just one API. Sometimes we have many APIs in a system, right? APIs generally are described in a component called controller. So again, if you have access to the code base for the development team that you are part of, just go ahead and look for controllers, and you see things like the methods that will be used for your REST API. You see the endpoints as well, because everything is described there, okay? And then we have Swagger or Open API, the spec definitions for those APIs, right? This is more or less how things works when we are talking about a REST API specifically, right? I hope this diagram brings you a little bit more context, because as soon as we start moving on here in this content, you kind of understand a little bit more about how those API strategies matches to what we are seeing here. And you understand what are the importance of knowing this big picture, okay? So let's during the introductions here in the starting point, the crew of the event asked you guys to interact, right? So send out the chat. Have you guys already look at a diagram like this? How much familiar are you with this kind of architecture? I will look at your messages afterwards, okay? So let's move on. Because when we are talking about the basics on how to test an API, we have probably these 5 would be the well-known ones, right? Ways to test an API. So the first one is you go there and you input some data into the requests, you send the requests, you change the data, you try again, maybe you try a different type, different than what is expected, right? Another way would be to focus on business rules. So you know that there is a business rule that will be activated as soon as you click and, sorry, not click, right? We are talking about APIs. When you send a request with a specific property that when there is a value greater than 100 will trigger a rule, and when it's not, it will not trigger that rule. And if you have 2 different properties with a specific value, it will trigger a specific rule. Do you know what I'm talking about? You are using the API to interact with the system. So you are sending this information in order to evaluate if the API is working as expected. Then we have compliance with JSON schema. And when we're talking about compliance with JSON schema, I'm talking about you look at the response, right? Writing generally in JSON. And then you compare that with the Open API specification, the spec, and then you evaluate if that schema is correct. And then we have non-functional requirements, which is, for example, performance, reliability, and then you look at it. And then after looking at that, you'll be able to understand if what are the requirements that should be evaluated, and then you evaluate that on against your API. And finally, authentication and authorization, which is when you want to validate if your user has access to the system. And then when we are talking about API, it could be reflected in getting tokens, right? And then you have also the other perspective, that is to to evaluate if the user has proper access. So if you are a user that is a admin, for example, you can register, you can save, you can edit, right? But if you are just a standard user, you can just consume the information. So you need to validate that as well, right? So these are the well-known ones. Do you know another one? This is probably the ones that everyone is doing on your day-by-day work, right? And then before to move straight to the AI approaches, I would like to just show you how it looks like, to test something like this, right? Basically, the person will need to use a tool like Postman, for example, to add some information about the API. They will change the method, they will change the URI, they will change the body, they will send these requests. We'll look at the status code to see if everything is doing well. Maybe they do some changes, right? They know that it's important to send username and password, but then they send only the password, and then they evaluate if the status code is the one expected. They change that, and then they go to authentication and authorization. They change the password, and then it will reflect on a 401, for example, to evaluate if the API is correctly interpreting that the user doesn't have access, right? And then they can, for example, look at the structure of the token that was generated, and then after looking at that, they can probably select, they can use this token for many other activities. They can compare the response to the specification in order to evaluate if that is working as expected. So as you can see, I was expecting a token in the response and a 200, and then when I look back at the response that we got before, it is a 200, it has the token, right? I can also do non-functional testing, evaluating the performance and how long it takes to load the response. So all of these types of tests that we saw previously in this slide are things that you need to know previously, right? You will keep executing those type of tests. The thing is, there are more, right? You can have other tasks that you want to do. And in the day-by-day work, you are not only focusing on those 5 ways to test. There are many others. And here, what I brought to you, as I said previously, are 6 approaches that you can use in your day-by-day work, and that you can rely on AI to help you to drive that in a more productive manner, right? Because all of those tests that we were looking previously, they are tests that you need to do, but sometimes they are very mechanical and they are very time consuming, right? The idea here is to try to understand how a Gen AI tool, a Gen AI service, can help us to implement these 6 approaches here. The first one is how to create test automation based on a specification. So since I have a open API specification or a Swagger, I can use this Swagger to create test automation for me for my API using some frameworks that are, how to say, used by my team in the company that I work for. This is what we are going to see here in the first one, specification-based test automation development. The second one is automated test script refinement, which is APIs are changing, maybe not so frequent as UI, but they are changing, right, through the time. So if I have a change in the API, what happens generally is that the Swagger will change as well, or the Open API will change as well. So what I need to do, I need to take this specification and use GenAI to navigate through my test automation scripts, and then be able to identify what are the mismatches. And identifying the mismatches, the GenAI tool can provide me what should I change in that specific code, in that specific test automation code, instead of going by myself, looking one by one at the changes and trying to identify it by myself. Do you understand? These are kind of stuff that was very difficult to do before to having GenAI in the world. So the third one is JSON schema validation. So if I need to validate the schema that I have in the response, I need to think about ways to do it in a more productive manner. And one way to do it used to be JSON schema. Do you know JSON schema? If so, please mention in the chat. JSON schema is basically a syntax that you can use to create huge validations against JSON. So if you have a response of a endpoint that you just hit, and this response have 25 properties, and you are not using JSON schema, what you are going to do? You are going to assert all of those 25 properties. If you have JSON schema, you can do the same thing using just one file. This is incredible. So this is one way to do. However, it's time consuming as well, because to create this JSON schema is not something that is really easy, right? So mock implementation based on logs. If your API call an external service or another service, you can use the logs that were created during those execution to create mocks automatically using GenAI. Also, you can test the JWT token, the internal information inside that. Used to be something manual. Now we can use this by leveraging GenAI. And finally, if you think about the logs of your API, you will probably see a lot of information inside, information that are rich information that can help you to learn from that. So why not to look at the logs and create test automation for the error-prone areas inside it? Maybe all of these 6 are just ideas for you, but I also bring some demo just to show you a little bit more how it works. So first one, creating test automation based on specification. So here what you see is a open API spec on the left side, okay? And then you see the logging, you see the parameters that are inside, and everything that we need in order to do a logging. And then here on the right side, you see the code that was used to renderize the screen on the left. I'm talking about the OpenAPI spec itself. It's a file, and generally, if you don't have access to it, you can talk to your developers, right? So as soon as I select all of this specification and I copy, I can go to a GenAI tool, for example, ChatGPT, and start creating my prompt. And this prompt will basically say, hey, look at the specification below that I'm going to provide you. And I'm talking now about the Swagger in this case. And then I say, hey, and also look at all the status the status codes that you will find in that specification. And after knowing that, go ahead and create test cases in an automated manner with Java, JUnit, and Rest Assure in order to cover all those status cases, or all of those status codes. And here you see, and I also delimited a little bit saying, hey, do this only for logging. And then you see that the tool was able to look at the specification and come with test automation scripts based on the tests that will be needed to cover those status codes. The data for sure are mock data, right? But as you can see here, the tests that we have here were covering all the status codes that I have in my spec. And this is what is important as well, right? I need to look at the result from the GenAI and then look back at my source to evaluate if the scripts are created properly. And here you can see we have 4 status codes. And on the GenAI tool, we have also 4 status codes, right? So this is how you create test automation based on the spec. And one thing that I need to mention here is, in order to do it in a right manner, try to think about criteria on how you can how to say, drive the GenAI tool. Instead of just ask for creating tests, think about criteria that can be very good to you on the test automation coverage, right? At Capco, we created a product, which is a solution that helps testers to create test automation based on Swagger. And then we used all the criteria that we learned in our large experience testing softwares to give this, how to say, this criteria to a tool that use GenAI in the backend to create the test automation scripts in a way that we are going to cover, to have a good coverage. So if you want to learn more about it, just reach out to me, and then I will be more than happy to talk about it. The name is Test Genie. So second one, test automation refinement. And as you can see here, what we have is basically a Swagger again. And this Swagger is looking at the, and here I'm looking at the Swagger. And looking at the Swagger, I see that the attribute password was changed, right? It used to be Senha, and now it's password. And how they say, in order to me to detect that, I would need to go through all the specification in order to identify that. But with GenAI, I can just make a prompt and say, hey, look at the Swagger, and now go ahead and provide me a list of fixes based on the mismatches that my test automation have in regards to the Swagger itself. So I will compare here the specification with my test automation scripts, and then after doing that, the GenAI tool will basically identify that all the fields that was changed in the specification now how they say were identified, and then the GenAI tool will generate to me what are the changes that I need to do. As you can see here, after doing that comparison, some changes were proposed. So the GenAI tool identified where I still having mismatches fields, and then started to propose these changes. And then what I need to do is just go ahead and select and change those things. Okay. JSON schema validation. What I used to do to evaluate JSON schemas before GenAI was something like this. I go to the specification, I get the model of the response, I copy that, and then I go to I used to go to a website like jasonschema.net, and then I paste that model, and after submit, it will create for me the rule that I need to use to evaluate the JSON schema of this application. However, nowadays with GenAI, what I can do is a prompt like this to read the test automation, to read the spec that I will provide, and then based on that spec to create some test automation scripts to validate if the JSON schema is appropriate. So what I need here, I need to for sure give what is the model, right, that I will have in the response, and then ask the GenAI to create the tests to literally demonstrate how to validate if the JSON schema is good enough. And then as soon as I do it and I provide the specification, what I'm going to have as a result is first of all, the dependencies that I will need to create this project, and also the tests. And as you can see here, since Rest Assure, which is the library that I'm using here in this example, has already a method that is called match JSON schema and class path. The tool is proposing me to create the class path with the specs, and also to create the tests that will match the JSON response body with the JSON schema in the class path. So in order to do it, you need to understand, first of all, that JSON schema exists and how it works, and then ask the tool to create those tests based on the validation of the schema by using a GenAI tool. Then we have this one, which is very useful, that is to create mock implementation based on logs. So how it works? Here at my logs, I will see these external calls. These external calls are my API sending requests to external services. However, these external services may be not ready or not up. And then what is going to happen? My API will fail and I will have troubles. In order to avoid this, one approach is to create mocks. So what I do, I copy that excerpt of logs, just a piece of those logs, and then I asked the GenAI tool to read those mocks or to read those logs and come with some logs. So as you can see here, the prompt that I did was, hey, go ahead, read these logs and create mocks for every single external call. And after doing that, I will paste the logs, this excerpt, and okay, let me show you here. Okay, and then after asking the GenAI tool to create those logs, it will create based on any tool that you prefer. For example, there is a tool that is called Mountbank. Mountbank is like a mock server that you can use to create mocks. And then based on on those logs, ChatGPT in this case created the mock servers for me automatically based on the logs. This is very easy. Instead of if you don't use GenAI to do it, you probably need to identify one by one and creating by yourself. This is one thing that accelerates a lot the process of creating mocks. JWT token. Again, when you do a login using an API, probably what you have back is a token. And behind this token, there are some architecture, some structure and data. So I copy here and I use this website, jwt.ms, to paste the token and see what we have inside. Before GenAI, I need to do it by myself to read the log and then create my tests. But using GenAI, you can just ask for reading for decoding that JWT, and then after decoding that, to create some tests using the tools that you prefer, right? So what I did here in this prompt was to ask ChatGPT to decode the token and then validate everything that I have in the structure. And then I paste the token, and at the end, what we are going to see is that some libraries will be required to do it, to decode the JSON JWT token. However, at the end, you see, let me now. After doing the login and get the token was decoded, and as you can see here, by itself, ChatGPT identified that we have an ID to be validated inside it and the username as well. So that's how you can use a GenAI tool to validate the JWT token. And again, it's something that would require a lot of time before. And the last one here today is this. Error scenario API testing. So inside the logs, you will track a lot of errors that will happen when the API is being used, right? So you can see here many errors. But what are the main ones? What are the ones that happens more frequently? In order for you to do that, you need to read the log, and you take a lot of time to identify those areas. But here, what I did was a prompt to read the logs and then identify the error-prone areas and come with test automation to help me to identify what should be tested. So my prompt here is giving ChatGPT this set of logs and asking, hey, come with the tests for the areas that are more passable of errors. And then as soon as we have that, you see what are the areas itself that are prone error areas. And then again, you need to get back and to do your verification based on a sample of those logs in order to evaluate if the tool did the work correct. But at the end, you will be able to create test automation scripts based on those prone error areas, and then you will be more covered against the things that most happen more frequently in the usage of the API. One acknowledgement before I finish my talk today is that you need to be responsible when you are using AI-driven API testing. Because in order to evaluate the result, you need to have knowledge enough related to the actions or the prompts that you are asking for the tool, right? So instead of just go ahead and ask something to ChatGPT, go ahead and look at the output and evaluate if the result created was good enough. Don't simply judge that as correct. Go ahead and do a fine, a really deep review before to just go ahead and to instead of just go ahead and rely on the results. Okay. So as I said before, I work for a company called Capco. If you want to know more about Capco, we have the capco.com website, or if you want to just reach out to me. And if I still having time for questions, would be a pleasure to answer. If not, you guys can reach out to me on the social media. I will be more than happy to talk to you and to answer your questions. Thank you so much. Back to you guys on the organization of this conference.
Thank you, Julio, for that insightful keynote. We hope you found it valuable and picked up some great takeaways. Now it's time for the Q&A sessions. If you have any questions, please feel free to put in the chat. All right, I think we have received few questions. All right, so the first question is from Dulaj Gamage. How can I test an API that is a part of a background cron job? In our application, we have several background scheduled tasks, and it takes about 5 minutes for the results to be returned. Is it possible to automate the testing for this, particularly to check the status? If so, how can this automation be implemented? Over to you, Julio.
Okay, thank you for the question. So what happened is that when you have this asynchronous validation, you need to think about testing in a different manner, right? When we have synchronous ones, it's as easy as I showed in the examples. You just hit the API process and return the result for you immediately, right? When you are testing this in a asynchronous mode, you need to do maybe 2 or 3 parts. Divide that in 2 or 3 parts. One is the one that you trigger the process, right? For this one, when you trigger the process, you can do from an API perspective, right? You can just hit the endpoint and then see that the process was triggered, and then you look at the responses and you'll be able to evaluate if the trigger happened. Another one, that is the third one, is when the process is already done. So you can just hit the endpoint and then check what was the results of the processing. But what happened in between, it should be tested in other ways. For example, a way to do it is to use tests in a more lower level. So instead of just go ahead and test from the API level, you can test from a code level. So you can pair with your developers and start testing the methods that are being called behind the scenes. So instead of to testing a REST API level, you can test on a code level, testing the services, as I showed in the diagram before, testing the repositories, testing the controllers from a code perspective, because there you have more control, you know? Because when we are talking about a asynchronous process, you have many things happening, you know? This is the approach that I recommend. However, sometimes the team, for some reasons, decide to create a kind of a tracker for the process. Do you know? And a tracker would be like a REST API, a REST endpoint that you can hit and see how much processed that service already were. Do you know? So in this case, if you want to do some closer to real, you can keep hitting that endpoint and understanding how complete, how done is that, do you know? Which is not an approach that I recommend. However, I'm here to just share my thoughts. This is another way that can be done. Best one, pair with your developers, test in a lower level. It will be better and in a better action for sure.
I think you got the answer for your question, Dulaj. So next, in the questions list, I think we have a couple of questions related to the Gen AI and Gen AI and testing scenarios. So maybe we can go through the questions together. So I can see that like most of the questions are related to how do you suggest to manage privacy effectively given the openness of AI systems, and also there's another question asking, is there any other AI tools you are using these scenarios? And also one person has asked, what are the risks you see when you use the generative AI for API testing? If there are risks, what are the mitigation strategies you use? And also, I
Okay.
think they're concerned about whether Gen AI will replace physical engineers on premises, such as I
Okay.
think, yeah, I think all are the same in the same domain. So can you go through that, Julio? Yeah.
Yeah, sure thing. So let's start with the first one that is related to privacy. When we talk about privacy, let's talk in this way, okay? Nowadays, the Gen AI tools provide some how to say um, different models on how to deliver those AIs, right? So you have the privacy established by the terms and conditions on the contract that your company sign with the Gen AI provider, right? For example, when you start using a Gen AI, whatever it is, the company that is how to say on the other side providing the service will give you some conditions saying, hey, we are not going to use your data. Nowadays, companies understand that, and they will how to say um, they will believe in this how to say contract between them and the Gen AI provider, right? Apart from that, there's no way to just how to say, for example, use a different prompt to assure that your data will not be used how to say further, so it's more about a contract between your company and the company that is providing the service itself. So this is the answer for the first question related to privacy. It's how to say a deal between your company and the company that is providing the service. The second question is related to the risks related to test automation, right? One of the risks that I've been facing when I use Gen AI to create my test automation is to how to say mislead the tool. Because what is more easy to us is to just copy the JSON schema, or to copy the the REST API specification, paste that in the Gen AI tool, and say, write test automation for me. It's not the better way to do it. Do you know? Let's imagine that me and you are working together, and then I come to you and say, hey, this is the spec of the REST API. Go ahead and create test automation for me. What is the first thing that you are going to ask me? What is the scope? What do you value most here in this test? What are the tests that you want me to start with? Should I test everything? Because everything is a lot. Do you know, I'm talking about more than 150 tests. Is that what I want? What do you want? Do you understand me? However, when you ask the same question to a Gen AI, what it is going to do? It's going to just start generating stuff, and then you believe that the Gen AI tool understood what you asked, and it not. We need to be careful, and we need to be wise when we are talking about Gen AI tools. They are not, like Aladdin and the guy that will just grant all the desires that they want. It's give the proper instructions. So in my demo, I say, hey, go ahead and cover all the status codes that I see here. And I don't have a lot. I don't know, maybe four for logging. I can see if the tool created that correct, and I can check against the spec to see if those are created properly. So be careful related to the prompt, be straight instead of be open, as a human being would do, you know. And then the last one, can you repeat, please, Darren? I think I forgot the last one.
Yeah, the last question was about
Oh, it's
what are
related
the
to human being replacing,
yeah
right?
that's about what do
Okay.
you think about the future of software QA with the Gen AI? I am asking
Mhm.
about the requirement of physical engineers on premises.
Okay, perfect. Thank you. So let's think in this way, okay? There are in the market, there are testers that, how they say, are updating their knowledge, learning more, refining whatever the activities that they do, and understanding every single day more about the profession of a software engineer, right? Because we are all software engineers at the end. They are studying a lot. There are others that are not. They are just stuck on the very same place that they are 5 years ago. Okay? And there are managers that knows a lot about software engineering and quality, and there are managers that does not. Okay? When a manager that doesn't know a lot about testing, they see ChatGPT doing some things that I just show to you guys now, and they don't understand nothing about testing, what they are going to do? They are going to say, my testers can be replaced. If you are a tester that study a lot and keep how to say growing your skills as you guys, because you are now, watching this event here, you know, if you are these guys, what you are going to talk to your manager? Hey, you don't understand the risks. You don't understand the mechanics. My work is to do more than that. Let me show you. Come here. And then your manager will think, oh, I didn't know about it. This guy knows what he is talking about. And look, I understand now that it's impossible to be replaced by Gen AI. However, if you are this tester here that doesn't study a lot, that doesn't know about your role, when your crazy manager come to you and say, "Oh, I will replace you by Gen AI," you will not be able to even provide a understandable argument that will change his mind, because you are not caring about your career. Do you know what I'm talking about? So if you are here as this tester, you will not survive. I'm sorry, do you know? Because when we are talking about Gen AI, or every these new, how to say, tools, they are very, how to say, enchanting, do you know? And those crazy managers that doesn't know a lot about testing, they will think that you are replaceable, and they will replace you because you don't know how to defend yourself, your work, your role, the strong, how to say, position that you play in the team. Okay, so said that, what I was going to say is, if you don't understand deeply your role, you probably will be replaced by Gen AI in some moment. However, if you know your role, if you are strong on foundations, if you know how to position yourself, you will never be replaced, because you will use these tools as a supporter for you.
Okay, thank you once again, Julio. Thank you so much for all your questions. For the rest of the questions, Julio, it would be great if you could type the answers in the chat. Due to the time constraints that we have, we will have to move to our next session of the day. Okay,
Hey,
so
thank you so much, guys. You are amazing. I felt at home. This for sure will be a great conference for everyone that joined us today. Thank you so much. It was a pleasure to be here. And yeah, let's connect on the social media, okay? Thank you.
thank you. It is our pleasure to introduce Chatura Bashika, Senior Software Engineer at 99X. Chatura Bashika is a full stack developer with over 4 years of experience in building scalable enterprise-grade applications. He has worked with global clients including USA and Norway, contributing to products such as SuperOffice, Payco, and Compilo. While his main focus is full stack development, Chatura has a keen interest in end-to-end testing and has helped integrate Playwright into various test E2V suites. He is constantly exploring new advancement in Playwright and is currently working as a senior software engineer at 99X, where he drives impactful software development and testing solutions. Today, he will be addressing the topic, how can Playwright fixtures solve my testing challenges? A must hear for all the testing enthusiasts. Over to you, Chatura.
Yes, yeah, thank you for that great introduction, Tayunya. Let me grab the screen. Yes. So last year, we were asked to initiate an end-to-end test suite for our project. So by then, our team didn't had any experience with Playwright. So what we did was took some time off, learn Playwright from the scratch, and then we ended up get our test suite up and running. But as we gradually adding new tests to these our test suite, we started having these annoying issues. So we ended up duplicating a lot of codes that made maintaining our test suite very, very difficult. And we had to repeat a lot of logins in the test. So that actually made our test suite very, very slow, very time consuming. And also we had some scenarios like user role-based feature testing. So actually that's when we found out about Playwright fixtures. So actually Playwright became a lifesaver for our end-to-end test suite. It solved a lot of problem in our test suite and made it better. So I'm Chatura Bhashika, developer at 99X. So over 4 years of experience developing web application. I have written countless tests from low-level unit tests to high-level end-to-end tests. So today I'm sharing with you guys how we have solved these challenges we have faced in our end-to-end test suite. And by the end of this session, I hope you will also have some insight on how can you use Playwright to solve your testing challenges in your end-to-end test suite as well. So let's begin. So by now, you have this question in your mind, like what is Playwright fixtures? And what is Playwright? And most importantly, what is a fixture? So next few slides will focus on that. So when you have better understanding of the words, we can better understand what I am trying to present here. Yes. So imagine you're going to see a stage play, a stage drama. So now you're sitting in the audience. So there's a table and a chair just placed dead center of the stage. Lighting is set. Looks like the play is about to begin. So everything is ready. So you're waiting for the actor. It's just about to start. So everything in place. So just like that, you could think fixtures similar to this. So just as this chair and table, which actually called stage props, need to be in place in certain way in the stage, and the lighting has to be set in a certain way. Same like this in your test, there are some setups and arrangements you have to make before you start your testing. So fixture is just that, like whatever the steps that you need to run before your test. Some examples would be that you need to navigate to a dashboard before you're running your test in the dashboard. Maybe do a login before you testing anything in the homepage, or just clearing a local storage before you run. These could be the great examples for a fixture. So Playwright is a testing framework, which is a framework we have used and main focus on this topic as well. It's a relatively modern testing framework. The key feature or selling point is actually cross-browser testing. It can test simultaneously with a lot of browsers, and also by default, Playwright runs parallel, so you get faster executions, and also it supports many languages. So what is a Playwright fixture? So Playwright fixture is a reusable setup code that you can share across your test. So what you see here is actually a test block written in Playwright. And if you notice that in square brackets, there's a page that is actually a built-in fixture in Playwright. So if you have already been using a Playwright, then obviously you have used this page, which is actually a built-in fixture. So you can use page to do navigation and stuff. So here, if you take a look at this test block, what happen is like you request this free picture because you need it in your test to run. And then from this picture, you just navigate to this page. And then at the end, you just check whether the title is Playwright in that page. So there are other building context pictures as well. The context picture is gives you access to browser sessions and stuff. Yeah, that's all built-in pictures. But actually, you can create your own in Playwright. You can create custom pictures. So this is a custom picture that is created. So it's called homepage. So what does homepage picture do? It'll set you up a homepage. It'll do the login and then navigation. And once these pictures executed, you will have a ready homepage that you can start testing. This is maybe some complex logic syntax here, but you can obviously go to documentation and know about it, but I'll briefly go through. So this is actually extending the test object from the Playwright. So that means whatever custom fixture you add, you will add to the existing Playwright objects. So you'll have existing built-in fixtures and your custom fixture when you use this fixture. But how do we use this fixture? Just by requesting it, like this. In the right hand side, you see inventory spec. That is testing something in an inventory system. So it's testing something whether that item catalog is displayed or not. To do that, you have to log in. So here you see that in the square brackets, there's a home page, which is our big custom fixture I have requested here. So in your test code, you now have a home page fixture. But how does this work actually? Like, what is how it is executed? Is there order? So let's just focus on this test block here. So what happens first? So what will happen is before running any test in your test block, it will resolve all the fixtures because fixtures are basically dependencies. So once playwright see this fixture, that playwright knows that you need this fixture. So it will go first to the fixture and start executing. So it will start from the setup logic, go to the page, enter username, password, login, and it will come to this line. This is the use is actually a callback to your test block. So when you execute this, it'll go back to your test block, and then it start to execute your test. So because you already log in and you have a home page, now you can start. So after executing your test, after everything is done, it'll actually come back again to the fixture to do the tear down. So the earlier what we did was login and everything is set up logic, and then at the end tear down. Then fixture is finished, your test is also finished. Yeah, so that's how what is a fixture and how fixtures are in Playwright Acts and stuff. Since you now have some basic understanding on what is a fixture, what is a Playwright fixture, and everything, we'll get back to our topic again. So I said, as I said, we have faced some challenges, but since we have not enough time to discuss everything, I have picked 3 challenges, which are called duplication, repetitive logins, and finally testing with different users. But before diving into each of these, I think it's important to know the value of why solving the challenges matter. So as for the code duplication, when you have code duplication, it's hard to maintain. So by reducing the code duplication, it will be very easy to maintain your code. And when there's a new developer come, it will be much easier to get adapted. And then when you have repetitive logins, that will actually increase your test suite time. So it'll hard to maintain your test again. And so this is like there can be features that requires role-based testing because the behavior of these features will depend on the user. So testing these kind of things might be a little bit tricky. So finding efficient way to do this also will be very beneficial your test suite and also testing in general. So you have more robust test suite. Okay, and now that we know that, let's dive into each of these challenges. Let's start with the code duplication. So what you see here is again trying to test something in inventory, some kind of inventory. So here you see 2 test blocks here. The test at the top is testing whether the item catalog is displayed or not, and then at the bottom it is checking whether is there a card add to cart button in an item. But what you notice here is, which I have highlighted, is both of these tests have now setup logic or login logic. So this is obvious code duplication. So not just Playwright, a lot of other testing frameworks have offer these setup functions like before each, after each, to actually solve these kind of duplication. So what you see here is exactly that. Compared to the earlier, now I have placed all the setup logic in before each. And if you look at the test blocks now, you don't see any setup logics in there. They have gone to before each. This is good, but we have some limitations here. So limitation of before each. First one would be that you cannot share setup logic because you have to specify a before each in each file. So in screen you will see two spec files. At the back, grayed out was our early inventory spec, but now you see at the top, we have a new spec file called card spec. So in the card spec as well, for these tests, I need to be logged in. So again, I am repeating myself in the before each, specifying the login logic. So that's one implementation because you have to specify everywhere before each logic. But there are more. So this is a scenario where like two test blocks having different requirements. So the test blocks I have highlighted here actually doesn't need to log in. Let's imagine that it's testing something in landing page, so you don't have to log in. But there's another test block that is testing something that actually you need to log in. So these are the two requirements. But by placing the logging logic in the before each, what will happen is even though your test block that doesn't need to log in will actually log in because regardless you need or not, before each logic will be executed. So that's another issue in before each. So by now you see that before each, I call before each, but in general there are setup functions to be before each, before all, or maybe tear downs like after each, after all. There are some limitations. It's actually not ideal to solve your for duplication issues. So what would be what is the solution here? So we have already talked about a good solution when we talk about custom playwright fixtures, which is actually the custom playwright fixture that we have talked earlier, the homepage fixture. So by using a homepage fixture, the first thing you notice here is you don't have to specify like setup and tear down in different blocks like before each, after each. Everything is in the same place. So when you export your picture, and then in the right hand side you see how it's used. Like you don't have to specify the setup logics in every file now. Just importing it and using it. It's like straightforward. And the limitation where some test actually doesn't need setup or logins. Actually, it's also solved because if you notice that the same two tests are here, like test that needs to login is at the top, and the test doesn't need to login at the bottom. So the test that needs to login actually requests the home page. So it will actually do the login, but if you don't need to login, you just don't request the home page. So you don't have to login. So actually, that is because features are on demand. It will be executed only if you actually request it. Yeah, so that's how that's a solution on with fixtures. How can you solve code duplication? Let's move to the second challenge. What you see is our earlier fixture, homepage fixture. At the back, grayed out, and at the top, the two test blocks that we saw previously that actually use homepage. Both test blocks actually using a homepage now. So there's a problem or issue that the fixture we have all created. So in these two test blocks, what will happen is because we request the fixture in both test blocks, the fixture will be executed. That means login will be performed. So for these two test blocks, 2 times the login will be performed. But imagine you have like 200 test blocks that is using homepage. That means your test suite will perform logins 200 times. So imagine that your logins also have MFA, so it adds up. Like it'll take like significant amount of time in your test suite to just log in. So that's an issue. So how are we going to solve this? What can Playwright provide us or Pictures provide us? We can solve it actually by using one of Playwright APIs and also how Playwright organize our test. So what you see in the diagram is actually the process and also how Playwright organize your test. So all your test you can place in Playwright project because Playwright actually organize your test on projects. And your projects can have dependent projects. So we can configure this in Playwright config. So what you see here is I call main project as inventory project, and it has a dependent project called auth project. So whenever you have a dependent project for your project, before executing a single test in your main project, all the tests in your dependent project will be executed. So that is what we're gonna do, like place our login logic in the dependent project or auth project, so that before coming to any single test in our main projects, the login will be executed there. So what you're gonna do is, this is in the auth project. Even though you see the setup, actually it's still Playwright. I have used this alias here. It's still the test object coming from Playwright. This is a simple test. So in this test, I merely just do the same process, login process. But what you notice here is there's this line called context.storage state. What happens when you execute this line is actually now once you log in, your browser has certain state. It could be some session cookies and session tokens and something like that. The login state, basically, you can save it to XML file. In this case, a JSON file. So when you save to XML file, that means you can reuse it later. So this is what are we going to do. So in our main projects, when we running our test, we can actually use this same file that I've saved the browser state and apply to our test. So this is the same picture I have updated with this approach. So now you see the old logging logic which had in this picture and it disappeared completely. So no login will be performed here. Now in this picture, it just reads from a file. So if you compare to the previous example, as I said, like if you had the earlier fixture with 200 test blocks, you will log in 200 times. But now if you use this fixture, which actually does not perform login, just read from a file, for your whole test suite, you will just log in one time. So 200 versus 1. So yeah, that is actually the solution we have come up with for the repetitive logins we're having. So let's move to the last challenge we are going to discuss today. So as I said earlier, so we need to test. There are features that actually we need to test with different type of users because the features behavior changes based on the user type. So this is a small example on that. Like here in the same inventory application, they are testing something based on the user role. So it is testing whether managers can add items and customers can not add items. So what you will see is actually again the login logic is repeated here, and then it's not ideal, of course, but what a solution for this might be that just like we created home page fixtures for login, we can create fixtures for each user. So managers, we have a manager homepage fixer and then customer homepage fixer. But you will find that like as we add new user types to your system, then it will be very difficult to maintain this because we have to create a new features for every user type we having added. But of course, there's more robust solution for this. We can extend our earlier solution, which is using that storage state saving to a file and then applying it. Rather than just saving for just one user, we could actually do the login for every type of user we have, and then save multiple files. And then in our test, when we need this type of user, we just apply that file, and then we instantly have a login state with that user. So what you see in this code is actually the setup logic updated. Instead of one user, I have used login as all the use of types and saving. Now you might see that our JSON file has a user role in it, so it will have two different JSON files for two different users. So let's see how can we update our fixtures, our already existing homepage fixture on this. So this is the update homepage fixture. But you will notice two things have changed here. The first thing is obviously saving or reading from the JSON file. Instead of a static name, now we have actually reading whatever the user role JSON file. But you will see that there's a new feature that has been added to this code. It is called user role. So user role returns basically a string. So in this case, it returns a string called customer. And also, if you take a look at the home page, it does have the user role as a dependent feature. And you might also see the browser feature, which is a built-in feature in Playwright. But since user role is a dependent feature of home page, so before home page get executed, user role will be executed. So as for this user role returns a customer. So what at the end, a page you will get is a login page that is logged in as a customer. So basically you have a page that is ready to go, but log in as a customer. But the question is, are we going to switch the user role in our test when we need or not? So here is that updated picture and how are we going to switch this user role. So you'll notice that there's a highlighted code called test.use as user role. So actually Playwright features are overridable. That means we can actually override their value. we can override the value using this test.use. But you'll notice something strange is like everything now wrapped in describe blocks. Why is that? That is because a limitation of Playwright. You can overwrite fixtures, but just once per file. If you want to overwrite multiple times in file, then you have to use describe blocks. That's a limitation. But so if you notice that now I have nested these tests into describe blocks. The top describe blocks actually overrides the user role as a manager. And then in that same describe block, any tests that actually use homepage will have a user role manager and then have a page logged in as a manager. It's same with the describe block at the bottom. So you override the role as a customer, and then you have a homepage logged in as a customer. Yeah, so that's how you solve the multi-user different testing with different type of users using Playwright. In conclusion, Playwright fixtures can solve a common end-to-end test. There are a lot more that we didn't have enough time to talk about. So, as an example, you can solve excessive data generation with Playwright using something called worker processors. This is also a common problem, excessive data generation. So I recommend you to actually use Playwright fixtures in your test because it can elevate your testing game and improve your test suits. Yeah, so that's it. Thanks for listening. Yeah, back to you, Dal.
Yeah, thank you so much, Chatura. That was a fantastic session. Thank you so much for shedding light on Playwright and its impact on testing strategies. So I can already see that there are some very interesting questions in the Q&A, but due to the time restrictions, please note that we won't be able to answer the questions live. But don't worry, we will be answering your questions on the chat while the next session is going on, and Chatura will be answering your questions in the chat. Yeah. So next, we have another exciting talk lined up. Please join us in welcoming Janit Gunasekara, the Head of Quality Engineering at Circles. Janit Gunasekara is a seasoned leader in quality engineering with extensive experience across e-commerce, telecom, healthcare, and CRM sectors. As Head of Quality Engineering, he manages global teams of professionals driving automation and compliance across SDLC. A recognized thought leader, Janit has authored articles and delivered impactful presentations at international conferences. His expertise in software quality engineering strategies, DevOps tooling, and quality transformation positions him as a mentor and innovator who is committed to advancing industry standards and fostering a quality-first culture. Today, Janit will be discussing achieving the perfect balance between speed and quality with test automation. Please welcome Janit Gunasekara.
Hi, Dharna, thank you very much for the introduction. Dharna, can you confirm the audible and the video?
Yeah,
It's all good?
Yeah, all good.
Yeah, let me share the screen. How about the screen? Can you see the screen as well? It's a blank screen.
I think, yeah, it's a white blank screen. We can see that.
Yes, awesome. Again, Dharna, thank you. Thank you for the intro and two good speeches. I think wonderful insights about ATST with the new trends, especially when we are talking about AI, and then we talked about Playwright and how you can improve overall automation. And if you look at automation and all, everything that we talked about is helping us to increase the speed. However, still, we have some questions, even when we go for a discussion, if you talk to a customer, if you talk to any delivery leader, any CEO, they always ask the question how we can deliver fast. You know that when you try to increase the speed of the delivery, the next thing that come into our mind is about bugs. What will happen if we increase the speed? Can we reduce the bug, or will that increase the bug count in production after release? If we do faster delivery, how we can ensure faster testing? Because when it comes to testing, it takes time. Automation, manual, whatever the strategy that we use, it takes time. So we have to see how we can. The question is how we can do continuous testing as well. At the same time, whatever the way that you follow, if bugs are leaking to production, that's a bad thing. So the question comes from business, question comes from leaders, how we can ensure that we don't leak bugs to production. And can we deliver fast with manual testing? How to reduce, because with the previous question, everybody's talking about automation. With automation, it comes with maintenance as well. So we have to see how are we going to handle all these questions and balance the speed and quality to get a faster delivery, better quality product in current trends. Because if you look at any organization, it's important that we deliver fast because we are competing with different competition, different timelines. And at the same time, we have to ensure that because of the competition itself, we can't have unhappy customers. We have to make sure that we understand the customer needs. For that, we have to ensure that whatever we deliver, we need to ensure that we have the right quality. So today's next 20 to 25 minutes, I'm going to talk about how we can balance the speed and quality with the tool of test automation. The previous session definitely will help us to understand more test automation aspect. This is not just test automation aspect. This is about how we do that balance part. So with that, a little bit of my background already Darren introduced that, so I'm going to skip that. So you see that we have speed and quality in balance, in a balance. If you typically what happens is that if you increase the speed of the delivery, traditionally quality of the delivery is reducing. And now everybody is talking about the quality is bad. When you try to increase the quality, it reduces the speed. So how do we balance this out? It's really important that we understand that right balancing point for our organization where we balance both speed and quality. At the same time, this balancing point might differ from organization to organization, starting from product organizations to a service organization. It might, for one company, the balancing point of speed and quality will be different to another company. So because of that, it's really important that we understand how we're going to balance it. So everybody's asking this question, how we can balance it, and some organization already balance it, and some organizations are in the path of getting to that the sweet balancing point of these two. So for anything that we are facing in our software development, always we need to start with the strategy. It's really, really important that we understand how we're going to achieve something. So even with this one, with the speed and the balance, speed and the quality, it's if you look at it, that problem, we need to break that problem and come up with a strategy so that we can achieve that. Even if you're planning to do automation, there has to be a strategy. If you are doing an overall testing strategy for the organization, then you need to think through. So even this approach, first recommendation that I'm going to give you is about coming up with a strategy. This strategy should be aligned with your business goals, your company vision, your company mission, and your product suite, your technology stack. All this should be considered, and then you need to come up with this strategy. So in this strategy, the first thing that we need to do is to get things faster. We need to go for the continuous deployment, which means that I'm not talking about continuous integration. Continuous integration is already using by many companies. So I'm talking about continuous deployment, which means that whenever you commit something, the change is going to go to the trunk, and the trunk will deploy that particular change into higher environments automatically and without any manual intervention. So it's really important. If you want to increase the speed, you need to bring the continuous deployment into your pipeline. When I'm talking about CI/CD pipeline, you know that continuous integration and continuous deployments and delivery. So first thing that we need to do is to ensure that we have continuous deployment. There are two things that I want to emphasize on under this. Those two are, I always recommend that we need to go for a trunk-based development. Reason is that when you have less number of branches, it's really easy to release something to production. When you have multiple branches that you need to work with, you have a lot of RC branches, you have a lot of feature branches which are like, living for ages. It's really hard that you can maintain a solid code base where you can release something to production anytime. Because of that, trunk-based development is a recommended approach, so that we need to ensure we do the trunk-based development. And also, we should build a pipeline where we can deploy something to production. I'm not going to talk about in this slide a lot, because I have a following slide I can talk about this aspect a bit more. And the next thing is that when you have continuous deployment, you need to have continuous testing, which means that every commit that comes to trunk should be verified before it deploys to production. So now you have speed. Now you are bringing the quality into the picture, where you're going to start testing everything using the pipeline. The next step is, okay, in the pipeline, what we can test? Are we going to test everything? Or are we going to test certain things? So there are a lot of testing types. So when you talk about different testing types, my recommendation are these things, and let's see how we are going to use these things in coming slide as well. So we need to understand, based on your product, based on your company vision, mission, business goals, what sort of testing types that you want and what you can bring into the pipeline. And I have noted down the general testing types. The next thing is that you have the speed, you are bringing the continuous testing. For that, you are bringing different types of continuous testing, and you are bringing something called, everybody knows about quality gates. So I'm specifically talking about hard gates, which means that, yes, we need to have quality gates. And also we need to ensure that these quality gates are hard gates, which means that if there is any changes coming in with failing the expected quality standards, you can't proceed from that gate onwards. So you can always guarantee the output that you are bringing in after code change. So that's why it's important when you test using different testing types, you also guarded these testing types with different thresholds. Now you can see that we try to go fast, we try to test fast. Also, we put conscious gates. For example, you are in a highway, you go fast, but then there are certain checkpoints. Speed limits is one thing, toll gates is one thing. So likewise, depending on your business needs, you need to bring this hard gate concept as well. So now you can see that our strategy to the problem that we talk about, the balancing or sweet point of balancing the speed and quality, we're talking about the strategy. So we are bringing the continuous deployment, and we are bringing the continuous testing, we are bringing the testing types, and we are bringing hard gates, which means that we are going to check constantly. And if nothing is up to the standards, then we're going to break it. The next thing is that, as just like any other strategy, for this strategy also, you need to have continuous improvements. It's really important that you have continuous improvements, because without continuous improvement, you can't improve what you are building. Because when you are transitioning from a traditional way of working to a modern way of working, there's a transition, that's a journey. In that journey, you need to have continuous improvements. So let's look back the strategy again. You are enabling continuous deployment to get the speed. Then you are enabling continuous testing. Then you are enabling different types of testing. And then you are guarded the pipeline using different types of gates on these testing types. And also we keep an eye on how we can continuously improve that, because this is a journey. This is not a destination. All right. So let's move to the next slide. Okay. So this is a typical trunk-based development where what you have to have is your trunk, and then you have a feature branch. When a developer make a feature branch to do a particular change, that particular change come into the picture, and then you do whatever you want to do, and then you commit or raise a merge request where the merge request is merged to trunk. As soon as it merged to trunk, it goes and deploy wherever your production environment is, which means that immediately that change will be reflected in user's laptop or user's desktop machine or mobile device. So this is the continuous deployment. So whatever you do changes right now, you are confident of committing that change should go to production immediately. That's about continuous deployment. The benefit of continuous deployments are we can ensure the speed, because without continuous deployment, if you have manual steps, it's really, really hard to achieve that. So for that, what you need to do is to ensure that when you create a feature branch, that feature branch should be a short-lived feature branch where all these code changes coming to the feature branch should be micro commits. You can't have thousands of lines where you develop for like 2 weeks. It has to be a few days. Maybe 1 day, 2 day, 3 days, or 5 days maximum, where you need to bring this change, and then you commit the change to the trunk. So it has to be micro commits, and commit should be going frequently. And feature branch, as a principle, we have to ensure that we keep it limited, and also things are getting deployed to production or but let's say to whatever higher environments immediately in an automated manner. When you say continuous deployment, there are different artifacts that we need to understand. When I say continuous deployment or automated deployment, that include the source code, that includes the configurations, it includes the database changes, it includes even schema changes, anything that needs particular code change to go to an environment and it is self-sufficient to work. Everything that you want to go there has to be automated way of doing it. It's possible. When we look at all these artifacts, there are different ways that you can get these things automated, and there are many tools available as well. And with this, you can't have any manual steps. You can't run a database script. You can't run a curl. You can't run anything. The pipeline itself, it should go and deploy to production or whatever high environment that we're talking about, depending on your organization. This will help you to get the speed of your work that you do as a team. Does it matter to the QA team? So far, no. This is a capability that we are giving to the product development team or the engineering team. However, you need to understand that with this one, our testing is going to change. As I mentioned, we need to bring continuous testing because now code is going to production continuously. To protect that code, you need to bring the continuous testing. So in continuous testing, what we need to bring it is, as I mentioned, unit testing, code quality. SAS means static code analysis for security vulnerabilities, integration testing, API testing, or even UI testing. And the last part is the feature testing. That is the new feature that you're going to develop with the work that you do. If you look at it, how we came up with these different types of testing, I always recommend we use the test pyramid. There was a question for previous session from the audience with whether we can start with end-to-end testing. I responded to that chat as well. I don't recommend to start with end-to-end testing. Look at your test pyramid. Test pyramid is about testing, integration testing, and then it comes to API. Even you can break into one microservice or one API testing, end-to-end testing from the API level, end-to-end testing from the UI level, and exploratory testing or any other manual testing that you want to do from the top as well. Even for the UI, there has to be unit testing. There are many unit testing frameworks available. So we need to bring these type of things. And also, it's not just unit testing, integration testing, or any other testing, but also it's really important and it's really easy to enable code quality scans, which will check for complexities, which is check for code smells, or any other rules that you want to ensure that your code is checked before confirming. You can bring code quality, just like SonarQube. Then also, it's really important that we scan for vulnerability scans as well, so that it will test. Now, there will be a question when you have continuous testing happening using different testing types. How are we going to? What are the principles based on our testing approach? One thing is that with the different types of testing that we're talking about, the first principle that we need to ensure is that, and most important thing is where you have to bring test. One principle is where your automation or different types of testing should ensure that there is no regression bugs leaking from your code. So it's really important. The first principle is that any new commit coming to the trunk will be tested with the intention of no regression bugs. And there's another principle: any code change done by the development team or the engineering team, they need to ensure that we support the backward compatibility. If we support the backward compatibility, if we test for no regression bugs, which means that the new code change or the new commit that we are doing for a new particular feature will go to production without breaking anything. Because no regression gives you the confidence, no new bugs on the existing workflows. Backward compatibility gives you the confidence where from the architectural perspective, there's no breakage. And also, new feature might not be used by the customer on the same day that you release something. It can be feature flagged. And it can be in a dormant code in production for a long period. There's no problem with that. Most important thing is that we send the code to production as soon as possible. And also, for the new feature that you are developing, you need to fast follow the automation, because there are many techniques. As the first speaker talked about, you can use AI tools where you can generate test cases much faster, so you can do automation much faster as well. And also, you can use different environment strategies like dynamic or static to ensure that you have the control of the automation that you're doing, because it's important that your automation suite doesn't break because of environment issues. So it's really important that you put a focus on environment issues as well and try to ensure that environment is undisturbed or protected with whatever changes that we do. So when you have this continuous testing with different types of testing, the benefit that you're going to get is we are going to get overall production quality protected, which means that once we release something to production, even though the code is going to production, your existing features are not impacted. Now you can see that we are allowing the speed to come into the picture, and also we are having different testing types so that you can go to production, because you build the confidence that things are not breaking because of different types of testing that we do. And then it gives you the benefit of we use it as big bang deployments. When you try to deploy a huge feature, all microservices or all the components that you want to deploy to production, you deploy something is breaking, customers are unhappy, there are a lot of incidents coming into the picture. All these things can be controlled when you use uh, continuous deployment with continuous testing to production. Right. This is a simple pipeline with different gates. Since we are almost 20 minutes, I would like to, I'll go to the next slide because this is the same, next slide is about the same thing, but with the concept of hard gates. So this slide, sorry about this, animation is about if code is going through this pipeline, any code with issues won't be promoted to production. Even it won't be merged to trunk as well. So we are taking a heavy stance on that, saying that if we want to have a pristine trunk, and if you want to have a stable trunk, and you want to continue to deploy to production, you can't make the trunk unstable. So you need to ensure that we implement our hard gates. So if you look at it from this diagram, you can see in the trunk when you take a feature branch, a developer can hold on. A developer can make the code. They can build and they can test it by themselves as well. When they feel they are ready by running their unit testing, by running their code quality, by running their whatever the integration testing that we want, then you can create the MR. And that merge request will go through different type of checks. So that will come into a environment. Before it deploys, it will build, it will run the unit testing, it will run for the code quality integration testing or the API testing you have, whatever the testing type that you have, will go through it and will be executed against that new commit comes or new changes in that particular PR and see these gates are meeting a threshold. For example, you are saying that we want 40% unit testing coverage. So because of new codes, if the 40% coverage drops, you stop the pipeline. You tell, okay, this hard gate fails. Please go and check it out. If your unit testing is failing, let's say you have 2 test cases failing, you stop. You say that you go back, fix it, and come back and again raise the MR or the PR. And same goes with code quality. You can say that how many criticals that you want to have, how many mediums based on your company. You can say that as well. If it goes and stop, then it stop the code promoting to trunk as well. And then even if you take API testing suite, right, for a single microservice or multiple microservice, depending on where you want. Typically, what we have done was since it's hard to work with a static environment, we bring our entire platform or entire services into a dynamic environment. We run that we up that environment with the test data management suite, and then we run our end-to-end API test scenarios against that new change to give that confidence that new change is not breaking anything in production. And once you build past that, which means that we need to have a threshold for that or a hard gate for that as well. So any API testing suite that we have for that particular source code or the pipeline, we have 100% pass rate. We maintain 100% pass rate. Even one test case fails, we reject the code. Because remember, the principle is that we need to have a stable trunk because whatever goes to production, whatever goes to trunk, it goes to production as well. So we have to stop that there as well. And then if you want to you want to perform your typical functional testing for the new change, then you take a break, put it into an environment where you test that particular feature. But the code is already in production because it is feature flagged and code is dormant, and that code didn't break anything in production, so that you can peacefully test your functional testing. And if the functional testing is not passing as expected, and we are not releasing that feature. Feature release and commit releases are 2 different aspects, right? So we do that, and then it goes to trunk. Everything is good, and then it goes and deploy to production or to a high environment like pre-production or a staging, and then you need to run a sanity to ensure that after this deployment, environment is stable enough to work with. If it is not stable, if your sanity is breaking, then you roll back the change, which means that you are keeping the production or that environment stable as well. Because your environment can break because of a new change comes to that environment. So you can see that we are bringing different types of testing, and also we are guarding these testing results or the thresholds that we set up, and then we can move forward. Right. Next one is, as I mentioned, we have to have thresholds. It could be coverage, it could be pass rate, and also if you don't have any testing right now, I suggest that we need to ensure that we get the coverage first before we start executing. Optimization in the execution, because coverage is more important for the speed. At the same time, if the execution takes a lot of time to execute, then it slows down, and that's where the optimization of execution come into the picture. And we'll talk about the plan of improvements in the next slide. Before we go to the continuous improvement, there is a question that everybody is asking. When you do such change using pipeline and continuous testing, how do you measure? We can't have a typical defect density measurements, number of test case executed, pass rates. Now you can see that pass rate is 100%, right? So you can't have fail rate. All these traditional things are going away. How are we going to measure it? Simply, we are going to measure these 4 things. Deployment frequency, how fast we can deploy. That gives you the measurement for organization. Measurement of the speed, deployment frequency, how often you deploy something to production, and then how long it takes your code changes done by a developer from a feature branch to production. It takes 3 weeks, then there has to be some bottleneck in between. So when you start measuring the lead time, it will give you the context of where the bottlenecks are. The bottleneck could be testing, bottleneck could be pipelines, bottleneck could be bad environment practice. There could be multiple reasons. So again, we need to see the lead time. Why we need to have a lead time measurement? Because it also helps us to understand our speed, and we can measure the speed based on lead time as well. Next thing is about change failure rate. Change failure rate is that's where the quality measurement comes into the picture, which means that how a bug coming into the production when you do a change, when you change the production. So change failure rate means, for a week example, you do about 30 to 40 deployments to production, and then you measure how many blockers that that environment has identified by different people in that particular environment. So number of bugs or production bugs divided by number of deployments, then it gives you a percentage. Typical recommendation is that when you do continuous deployment with continuous testing, your CFR should be less than 5%, which means that if you deploy 100 deployments to production, the allowance is about 5 bugs. It should be less than 5%. We do continuous deployment, we test continuously, and then we come here. And then also, we need to import, since we are giving a 5% 5% of bugs leakage, which is allowed for 100 deployments. We need to measure how fast we can recover if there's a problem, because if not, that 5% might create problems as well. So it's really important. When you do any transformation, when you do such change, we need to measure these aspects so that you know where you are heading. And the other part is the continuous improvement part. In continuous improvements, the point is we do all these changes and we believe that we have done everything. But when you go to production, there could be problems with UAT testing. There could be problems with production incidents. So now we need to understand why it has happened. So it's really, really important that based on these 2 inputs, UAT bugs and production bugs, we do a proper root cause analysis and understand why this bug is leaked to production, which gate missed it, where this bug in production is. If you understand that, you can go and ensure that you correct the problem. Not correcting is not enough. You need to ensure that you take preventive actions as well. What is a corrective action? If it is missed by API testing or UI testing, UI automation suite or the API automation suite, then you go and add a automation test case for that, so that in the future it won't repeat again. If it is a process improvement, for example, there's the requirement was not properly groomed or discussed between dev, QA, PO, SRE, or all these people, they have not talked about this feature, right? So because of there was a lack of communication, this bug caused in production. So that we need to go and fix that problem again, problem to ensure that we don't get something like that in production. So which means that in simple terms, continuous improvements will give you or will be the tool to ensure that repeat incidents are not happening in production, because we are eliminating the root cause by having corrective actions and preventive actions. All right. And yeah, this is a key takeaway. Whatever you start with the strategy. Strategy should align with your business goals, company vision, mission, technology stack, delivery model, and understand what type of testing that you want. Have hard gates. Start measuring progress. Have focus. Have a continuous improvement process as well, and build a culture. Because when you have a quality focused culture, speed and quality will be achieved, and you will go to that sweet spot of having a balance between speed and quality. Thank you, guys. Sorry, maybe I overran 5 minutes. Yeah, over to you, organizers.
Yeah. Thank you, Janit, for that insightful thoughts. It's been a really great session for all of us here. So now let's move on to the Q&A session. We can already see that there are a few questions, and the first couple of questions are related to I think, the continuous deployment you mentioned. So I'll merge two questions and give it to you at once. What are the risks we should consider most when opting for CI/CD? What were the challenges you faced when starting continuous testing from scratch? That is one question. And the other one is, isn't it too risky to have automatic deployments to production? Over to you.
Okay, I'll start with the second question. In Netflix, if I'm not mistaken, they do a deployments of 23 deployments per week or day. Amazon is about 1,000 deployments per day. And I mean, I just want to say that these things are happening, and we do continuous deployment to production, and many companies are also following that. Is it risky? That's where we need to have risk mitigation steps taken as hard gates or different testing types. Yes, it will be risky to start with. That's where we need to have a cautious approach, a strategy when you are doing a transformation like that. And if you do that, you can have, and it's not risky. I mean, something could go wrong, but then when you have a capability of fixing something, within 5 minutes, your system is recovered. Within a minute or two, your system is recovered, then your loss is less. So you have to have those capabilities as well at the same time while we are achieving the speed. The first question is, sorry, Dhanar, what is the first question?
The first question was, what are the risks we should consider most when opting for CI/CD? And what were the challenges you faced when starting continuous testing from scratch?
Right. So risk, I mean, risk is like this. Again, I told you, we need to balance the speed and the quality, and that tipping point or the balancing point is different to organization to organization. We need to understand the business goals. We need to understand company vision and mission, product strategy. We need to understand technology stack. We need to understand what we are trying to achieve. So it has to be a collective approach when you're trying to bring this, so that we can mitigate any risk that comes with the picture. And also some of the challenges that we have. So when you try to bring, for example, hard gate, which means that we are stopping the progress. imagine you bring automation suite with 100% pass rate. Every time this suite runs, it fails, and your suite has about a 10% flakiness, 5%, even a 5% flakiness, even a 1% flakiness. What will happen? Your progress will be stopped. And when you have 100 developers who are committing every day, and your pipelines are failing every day, that is a disruptor to the business or the BAU, right? Business as usual, it's interrupted. So that we need to manage these things, because we need to understand where these problems could arise. One is the flakiness. So if you have automation suite with flakiness, you're done. You can't have something like that. So we need to have way of making your automation suite, your automation framework, automation writing, scripting strategy, how you identifying UI components, how you identifying all these components. So you need to ensure that your flakiness is 0%. Is it possible to achieve? Yes. That's where you need to adhere to test pyramid, which means that you need to automate at the code level most. And then you need to build your automation suite so that you have only few UI testing that you need to execute. Even UI should be having unit testing. Like, there are many testing framework as well. So yes, that's very challenging. At the same time, going from traditional to this, it's a huge change, and it needs mindset transformation as well. It's not only tool. It's easier part is the tool. The tougher part is about changing the mindset when you're trying to do something like that, because we are stopping a developer's code going from one place to another place. That's very tough. So again, that it needs a lot of collaboration. It needs a lot of communication. It needs a lot of teaching, coaching, mentoring as an organization when you do a transformation like that. Those are the two challenges I see mostly. Other two challenges is about if you don't have anything, now if you have zero unit testing, how do you build your unit testing while your ongoing deliveries are committed to? For example, you need to start, you want to bring it up to 80% of unit testing coverage. How do you do that? So you need to have a small strategy over there. First one is, whatever the new code that you have, you are bringing the unit testing for the new code only. And then you set up a smart hard gate, which means that smart hard gate is where you have, if you achieve 5% of unit testing, you can't go down 5%. But somebody achieved 6% of unit testing, then 6% will be your hard gate. That's a smart hard gate. So likewise, you need to have a backlog clearance as well for unit testing, integration testing, API, whatever backlog clearance. Backlog clearance, my recommendation is that when you want to clear the backlogs, you need to have projects running separately. Your business as usual is running, your project deliveries are running, but you have a separate team in phase focus on clearing these backlogs based on your thresholds.
Yeah, Janet. We have one more question that it would be really good if you can give a quick answer. So the question is, would you recommend incorporating performance testing as a part of continuous testing?
Okay, interesting question. So when you say performance testing has a broader scope, right? So when you say performance testing, we can have benchmark testing, we can have load testing, we can have stress testing, and we can have spike testing. There are multiple testing types that you have when it comes to performance testing under the umbrella of performance. So we need to pick which one we can do it. For example, in a pipeline, every commit, let's say developers are committing 100 developers, at least 20 people committing every day. If you try to run a load test 20 times, too much and too expensive. So we can't have a load testing running in a pipeline. And spike test, same. Stress testing, same. But we can have benchmark testing, which means that we can run a benchmark test for a known load, maybe like 1% of the actual load, have a performance script running and measuring how that performance of that particular system varies depending on deployments or varying on commit to commit. That is something that you can run quickly. Maybe it's like very quick script. It runs and it collects the information like response time and whatever the metrics that you want and start measuring that. So when you have something called a benchmark testing. That's about benchmarking your code changes to a known thing. If you see a spike of that values, then you put focus and try to understand what has happened instead of doing load and stress testing, because those anyway need a separate environment you need to focus on, because these things are needed when a feature is delivered to production, and feature is not delivering every day. It is planned releases.
Thank you, Janice, for that insightful session. And with that, we have come to the end of our first day of sessions. What an incredible lineup of speakers and thought-provoking discussions. A big thank you to 99X, our strategic partner, for their continued support in driving innovation and excellence. And to SLSTB, our educational partner, for their dedication to shaping the future of software testing and professionals. Your support has been invaluable and we truly appreciate it.
We would like to extend our gratitude to our speakers, Julio de Lima, Chatura Bashika, and Janit Gunasekar, for sharing their valuable insights. Our sessions have been very helpful. Your sessions have been very helpful for all of us.
Of course, a huge thank you to all our attendees for being a part of this journey. We hope you gain valuable knowledge and new perspectives on software testing and quality engineering. Also, we'd love to hear your thoughts, so please take a moment to fill out the feedback form, which we will be sending via email. It helps us to improve and bring you even better experiences in the future.
Stay tuned for more exciting sessions coming up tomorrow. Until then, have a great evening and keep exploring new innovations in testing. Good night and see you all tomorrow.